Combined loading conditions are one of those situations where they may be complex, but if you break the complex down into a series of parts, before you know it, you've solved a very complex problem with a whole series of simpler things. One of the key things about this kind of situation is recognizing when it does happen. And you really have to be able to start to think in terms of 3 dimensions. So just go break it back down to something simple. And that is that there are 3 possible translations in the 3D world, and there are 3 possible rotations that might happen about those 3 axes that are associated with the translations. 3 rotations, 3 translations, and likewise, we have 6 internal forces which correspond to that very same possible movement. That's a little bit different than we're used to, but if you can get the internal forces in terms of those 6 quantities and then go find the basic stress model that goes with those, you've got it. That's all there really is to it. You have to do a little bit of addition of things here, but other than that, really, that's all there is ultimately to it. So let's look at a couple of cases and talk about what some of the potential issues might be. All right, so here we've got a pipe wrench on, of course, a pipe, and if we started looking at over here where the support is located, we got this simple 40-pound force there, and of course there's going to be a translational effect in that vertical direction. So right away, that's a shear as far as the support goes. But that's going to create torque about the x-axis. It's going to create bending about the z-axis. It's going to, this goes on and on, right? You've got a lot of things going on here. We don't have any axial. We don't have any bending about the y-axis. Those are 2 that aren't there, and we don't have any shear directed along the z-axis. So we do have, I think I counted up 3 of those effects that are going to be possibly present. Here's a cantilever beam that has a load out at its end, but it has 2 loads, right? It has one transverse load that creates the bending, and then you have the axial force. So you're going to get 3 total effects here internally. You're going to get the axial elongation, you're going to get the bending stress and bending deformations, and you'll get a transverse shear stress in the beam. And then we'll have to then go apply those basic models that we've learned. In this case, where you've got a little bit more complex of a system, both simpler and more complex, the ski lift on the left here has a tube that then comes down, wraps around, and then the chair sits on top of that. Right? Well, when you look at certain portions of that tube, A, B, D, E, and how it wraps all the way around, you're going to have both some bending effects as well as shear effects and elongation types of effects to have to deal with. The little front end loader assembly that you see here on the right, it's kind of interesting. We've got this little link AB there, and you learned how to analyze these systems back in statics. They were pin connected systems. You learned typically how to model trusses, and then you went into machines and frames, and this would be one of the typical kinds of machines problems. The little bracket AB is different than what you might have seen back there, and that is that although there could be, and certainly is, a straight line you could draw from A to B on that linkage, the thing is the actual mechanical piece is not a straight line. So if you've got these 2 sets of forces that are pulling and they're opposed, right, it's a 2-force member. Well, that 2-force member is going to try to elongate, but its whole orientation is not in that straight line from A to B. So it's going to try to straighten out. It's going to try to bend as well as elongate. So there'll be a combined state of stress in that linkage piece. And then you get down to this little, what you might think of as an engine lift over here down the bottom. It's another type of machine or frame. And the thing there is, again, you may have some pin connected pieces like that little pneumatic or hydraulic cylinder that's in there, but the member BC is going to have both bending effects as well as an axial effect, and so does AB have some both bending and some axial effects that are going to have to be modeled and included. So those are a series of realistic, practical, physical scenarios where you would have some sort of combined loading effect, right? So we're going to have a whole series of examples that we'll get into a numerical approach, and as well as some that will guide you through the conceptual analysis of those systems.